All right. Don't write this down, but what if I asked you to take this derivative? Okay, you have to know why.
I don't know, it looks confusing.
Okay. What do you have to do?
You have to distribute all of them so you have 9 terms.
Yeah. You have 3 terms to multiply to 3 terms. Don't do it, and don't write it down. You have 3 terms to multiply to 3 terms. Then once you get all that figured out, then you can do the power rule with 9 terms. I don't like that word, but it's a lot of work, right? Okay? What if I told you there was a way to do it so you didn't have to do that?
The lockout drill is complete. Thank you, everyone, for your cooperation. Proceed with your day. Now go learn.
The product rule. If you have a product, what does product mean? If you have 2 functions that are being multiplied together, we have what's called the product rule. Write it down and then I'll talk about it. You have the derivative of a product. We have the derivative of f times g plus f times the derivative of g. So you essentially have 2 pairs. And in each pair, you have a derivative with the original. And then the other derivative with the other original. Okay? Addition, is it commutative? Yeah. So if you switch those around, it's not going to be a big deal. As long as you have derivative of f times g added to derivative of g times f. Okay? So let's go back to that very ugly example. And we'll actually do it. So write down f of x, please. I usually prove to you why the derivative rule is a rule, but I'm going to skip that. I think you'd rather do examples. Okay. Number 1, do we have a product? If we have a product, then we can use the product rule. Okay? So our derivative. The derivative of our first function. So if this is our function x cubed plus 2x plus 5, our derivative would be 3x squared plus 2. Do you agree? So the derivative of the first times the second, and we keep it the same, plus, now we need a flip-flop. We're going to keep the first one the same, and then we're going to take the derivative of the second. So 21 x to the 6th minus 16x. Now I hear some whispers, like, oh my gosh, is this really any better? We're going to have to multiply these out. I am not going to make you go through the process of multiplying. If you get to here, I am happy. Okay? I care about the derivative process. Now, in Unit 3, we're going to use the derivative to do some things, and at that point, we would need to do some of that, but as of right now, I am just concerned about you getting the derivative. Okay? I'm going to have you stop. Okay? Did like a giant weight just like lift off of your shoulders? Just do it to begin with. Okay. All right, let's do another example. Okay, here is the beauty. All right, we have two different ways we could find this derivative. Okay, you have some choices now. Okay, let's talk about what those choices are. Right? If we were taking the quiz yesterday, we would say, okay, well, I can't take the power rule unless that's multiplied. So yesterday you would have done this. All right? Well, this is x to the 5th plus x squared, which means our derivative is 5x to the 4th plus 2x. Or we could use the product rule. We could say, well, this is a product, so we could take the derivative of the first, which is 3x squared, and multiply it by the second, plus keep the first the same, times the derivative of the second. Okay. Now, if we were to go ahead and like distribute this through, you can see that we still have 5x to the 4th plus 2x squared. Okay, we get the same thing. Some of you may prefer to do the power rule. Some of you may prefer to do the product rule. Or some of you may not see that we can do the power rule and just go straight into the product rule. It doesn't really matter. However you do it is fine. I just want you to take the derivative. Yeah.
You wrote x squared plus 1 instead of x cubed plus 1 on the right side.
Thank you. My powers were all over the place. Thank you for not being afraid to speak up. Sometimes when I'm talking and writing at the same time, like things get kind of crazy. Okay? All right, one more example and then I'm going to give you a turn. You ready? It is evident that we need to practice some trig. Okay, some of us got our sign, like our negative positives mixed up. Please make sure you look at that if that was you. Okay. Question to ask yourself, can we use the power rule? No, because we don't have just a term ax to the n. Second question, do we have a product? We have x squared times sine of x. Yes, we have a product.
Wait.
Now, we can use the power rule inside of our product rule, but just singular power rule to take the derivative, we can't because we have the sine of x in there. You see what I mean? Are you with me? Okay. Kind of a loaded question, sorry. I didn't think that through all the way, Anthony. Okay? So for our product rule. Okay, you're doing the problem. Okay. There are two functions. Everybody together, the derivative of the first. Times the second plus the first times what's the derivative of the second? Okay, now technically I wouldn't need those parentheses, but I would encourage you to use parentheses if any of your derivatives happen to be negative. I don't want you to think that you're subtracting when you really should be multiplying. So yeah, I can now rewrite this to 2x sine of x plus x squared cosine of x. And it looks fine and dandy. But I just want you to be careful with if you have a negative in any of your derivatives, having it in parentheses will help you see that it's multiplying and not subtracting. Okay? So I am going to have a question up on the board that has 4 answers. Based on those 4 answers, you are going to take your notebook and pencil and you're going to go to either corner 1, corner 2, corner 3, or corner 4. And each of the 4 corners will have a different problem, okay, for you to work through together to try to get to an answer. Okay? Make sense? Don't think too hard about this. It's really okay. Would you rather have a superpower, go stand by the door, meet the love of your life today, gather around right here, never feel tired, under the flag, own a time machine? To the couch corner.
Are you going to join us in corner 3? I don't get tired, so I'm tired now. But
I kind of like being tired sometimes.
Okay, based on your answer, and please, I don't want you to be working all by yourself, okay? Work together on these. Okay, so group number 1, you have the derivative of 2x cosine of x minus 2 sine x. Group number 2, you have the quantity x squared plus 1 times the quantity 2x plus 3. Group 3, you have the derivative of x cubed cosine of x. And group 4, you have 3x squared plus x times cosine x. Okay, my superpower people. You have 2 different terms. Which one of them has a product? So like I was just writing it what he said, so that you can
Oh, you're doing like minus 2 cents.
What if you 3x squared? You have 3x. Okay. So my suggestion to you, especially since it's x cubed times negative sine of x, I would go ahead and that answer would be fine. But for you, you could have subtraction. Okay. Are you my love of your life? Okay. What do you have?
It's like chocolate custom
I did invent some shit back then.
And actually, but whenever I did my knee, it was yeah, I knew I didn't want to try it. I got nailed. Sorry.
Okay, so let's start with
You have to keep this thing out here, but you can change the sign X to cosine X. So then this is a positive cosine X, and negative cosine X. And then you're just left with this.
All right, back to your seats.
This is negative.
So I didn't get mine.
Okay, let's prove it. Okay, so for the people who get to watch this video, I'm just going to put the answers up here. Okay, what operation do we usually group together with multiplication? And what's a division problem called? Okay, don't write this down. Here I have a quotient. Right now we have no strategy. Well, kind of. We could do the product rule if we wanted to. But it'd be we don't actually have the tools for that yet. So never mind, we can't. Okay? We have a division problem. We could not, like if this was just x squared, we could break that up. But we can't break this up into individual terms. Okay, like we can't write ax to the n power because that minus 2 is attached to the x squared. Okay, so we have what's called the quotient rule. Write this down. You don't have to write down my little hint down there. I'll talk about it, but this is something that Mr. Agreeable's class won't talk about because he doesn't like it. But it's just a way for you to remember it if you need it. Okay. What?
I said they have more homework than we do. Because I worked with one of the kids in their class, and they had to do 87 through 100 on the last assignment we did, and we had 3 in that grouping. They had to do 3 to 50 odds, and we don't have that many.
Yeah, really chill.
What? Should I give you more homework? Is that what you want? Okay. He doesn't split his up into required versus not. That's something that I kind of did.
So all kids are required.
Okay, so do you notice this numerator? Listen. Okay, so first of all, f of x is our numerator, g of x is our denominator. Do you notice how this looks kind of similar? What's different about it though? subtraction. So order matters big time here. So we have the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so this is how I learned it when I was 17 years old. Okay, low D high. So the lower function, denominator, times the derivative of the numerator. Minus high D low. The numerator, high, times the derivative of the denominator, low. All over low squared. So like low D high minus high D low. Just kind of has a little flow to it. Okay? You don't have to use it, but if it helps you remember it, there it is for you. Okay? Kind of like PEMDAS, right? Please excuse my dear Aunt Sally. It was cheesy, but it helped you.
Oh.
But like, please excuse my dear Aunt Sally. Like, maybe not everybody heard that. It's just a cheesy little. All right. Now write it down because we're going to take its derivative. Yes. Okay, are you ready?
No.
Oh, okay. Anthony and Colby, now are you ready?
No.
Okay. Are you, like, we're going to do this together. You know that, right?
No, I know, but
Okay.
I'm trying to do it.
Well, are you doing it by yourself right now?
Yeah.
Oh, well, no.
We're not supposed to?
Oh, we're
No,
not.
I was waiting for you to write down the example.
I thought everybody was like doing the
Like, are you ready? Like, we're going to do it together. Okay.
Oh.
So, our numerator. What's the derivative of our numerator?
3.
And then our denominator, we keep as is. Minus, now we flip-flop. We keep our numerator. And we take the derivative of our denominator, which is, okay. And then our denominator, we keep it and square it. Okay. This would be sufficient, but I'm going to go ahead and go all the way through. Okay. This would be fine for now. But what we could do is we could multiply that 3 through. We could multiply this 2x with the subtraction through. And just making it look pretty, we would have negative 3x squared minus 10x minus 6 over x squared minus 2 squared. That would just be making it look nicer, okay? Which is what the book is going to do, all right, with their answers. If you have this right here, I'm pretty happy, okay? I'm pretty happy. Well, I was thinking about that. I might do that, yeah. Yeah. Okay. I'll make an answer key and post it. I can't guarantee you that it's going to get posted. Well, it'll get posted by tonight. I'm just not sure by 3:30. Okay. What's the matter, Eli?
Nothing.
You thought we were going to be done?
No.
Oh.
No. I forgot there was a volleyball game, so I we might have to start earlier, because there's not a chance to do it.
You're right. You're right. Yeah, I grabbed it. Okay. Does anybody have thoughts on this example? What'd you say?
Power rule all day.
Like I can take the power rule right this second?
Well, you got read.
Okay, so Eli is saying, hey, we could rewrite this one. Eli, what would we rewrite it to?
X cubed minus 1 plus x negative second.
Plus?
I was bad on this on the quiz. I still don't know what it is.
Okay, Eli, do you agree that both terms are being divided by x squared?
Yeah.
Okay, so what's x cubed divided by x squared?
X.
And then 1 divided by x squared, we would write as x to the negative second.
Got it.
Is that better?
That
It's like 6.
So our derivative would be 1 plus 2 x to the negative third. Okay? Let's just say you didn't notice, like Eli did, that we could use the power rule, or you were worried about making a mistake on the power rule. We do have a quotient. And if we use the quotient rule, this is how it would go. The derivative of our numerator is 3x squared. We multiply that by our denominator. Minus. We take our numerator and multiply it by the derivative of our denominator. Okay. Do you believe me that these two are the same?
Yeah.
Okay. You're just going to take my word for it, aren't you? Okay. What we have, and this would be fine, but what we have is we have 3x to the fourth minus 2x to the fourth plus 2x all over x to the fourth. So if we simplify this down, 3x to the fourth minus 2x to the fourth, 1, over x to the fourth is 1, plus 2x over x to the fourth is 2x to the negative third. They are the same, okay? But if you use the quotient rule, we're really just going to stick to this up here. All right.
So you could stop up there if you wanted to, or would you prefer us to continue?
I'm okay with either one of, like if you combine these together, I'm okay. I wouldn't expect you to get all the way to here if we did the quotient rule. Okay. All right. This will go ahead. This will be our last example. Sine of x over cosine of x equals what? Oh, okay. You keep that. You keep that in mind.
I was about to start going.
We have a quotient. We can use the quotient rule. Okay? Quotient rule. Derivative of our numerator times the derivative, or excuse me, times just our denominator minus our numerator times the derivative of our denominator. Negative sine of x. Let's not forget that. Times the denominator squared. Now, we can make this look prettier, can't we? I mean, really, without having to think too hard, we know that this is cosine squared plus sine squared over cosine squared. Right? And this is just what?
Would it just be secant squared?
Okay, Grace, you said that this was tangent, right? Grace and Turner, somebody over there.
Grace.
Gonna give her the credit. Guess what we just figured out? The derivative of tangent is secant squared. You don't have to do the quotient rule ever again. The derivative of tangent is secant squared. What?
Like, is there a cosecant or a cotangent?
We're going to talk about those tomorrow.
How does it get to be 1 over cosine squared x?
Cosine squared plus sine squared, that's the Pythagorean identity. It equals 1. Okay. Okay. Let me go ahead and stop the recording.
You guys are